All right, let's get right into it. The skyscrapers, the bridges, really, the entire foundation of our modern world is built with one thing: concrete. But we're not talking about the same old stuff anymore. Today, we're going to pull back the curtain on the hidden chemical secrets that make modern concrete stronger, cheaper, and way greener than ever before.
But first we have to talk about the elephant in the room. There's a huge problem. See, the key ingredient in concrete is cement, and making it is responsible for a staggering 8% of all global CO₂ emissions. That's a massive number. If we want to build a sustainable future, we have got to fix our concrete problem, and the solution, believe it or not, is microscopic.
So, what is this tiny solution? It's something called a chemical admixture. Now, this is a very small amount of a highly specialized chemical that gets added to the concrete mix. It's not the cement, it's not the water, it's not the gravel. Think of it more like a secret spice, a pinch of something that completely changes how the whole recipe works.
And this analogy is just perfect. These admixtures are incredibly potent. They really are like high-performance drugs for concrete, and they're dosed in these tiny, precise amounts to get incredible results. When you get that dose exactly right, you create a kind of superhero material. But if you get it wrong, yeah, you're going to have some very big problems on your hands.
So what problem are these powerful drugs actually trying to solve? Well, for decades, engineers have been stuck in this fundamental trap, a dilemma that's at the heart of every single bucket of concrete that's ever been mixed.
It all boils down to this really simple trade-off. If you add more water, the concrete becomes runny and easy to pour. Engineers call this high workability, but the final product ends up being weak. On the flip side, if you use less water, you get incredibly strong concrete, but it's super thick and an absolute nightmare to work with. So, strength or workability? For the longest time, you had to pick one. But what if you didn't have to? And this is where the hero of our story comes in, a special type of admixture called the Superplasticizer. This is the chemical that lets builders completely shatter that old trade-off. It's the key that lets you have your cake and eat it too.
So how does it let you do that? Well, it basically gives you 3 new superpowers. 1, you can keep your mix the same but just make it flow like a liquid. 2, you can keep the flow the same but slash the amount of water to make the concrete way stronger. Or, and this is the real revolution, you can reduce both the water and the cement, all while keeping the exact same strength and flow you had before.
Okay, let's just break down what that third option really means, because it's a huge deal. For a standard batch of concrete, using a superplasticizer lets you take out a massive 100 kilograms of cement for every single cubic meter you make. Now, that 100 kilograms of cement obviously isn't free. If we look at a market like India, for example, taking that much cement out of the mix saves the builder roughly 600 rupees. Of course, this magic ingredient has a price tag. It's not free. The little bit of superplasticizer you need to add to do the job costs about 160 rupees.
So let's do the quick math. You save 600 rupees, you spend 160, that leaves a net savings of 440 rupees for every cubic meter. This is absolutely incredible. Think about that. You're not paying extra for some green technology. You are literally getting paid to use less cement, which means you're getting paid to lower CO₂ emissions and build more sustainably. It's cheaper, stronger, and greener. It's a win-win-win.
Okay, I know. It sounds almost too good to be true. It's an economic miracle and an environmental one. But how in the world can a few kilos of a chemical totally change the physics of a ton of concrete? Let's dive into the science. I promise it's pretty cool.
So if you could zoom way in, you'd see that cement particles are like these tiny, sticky grains of sand. And when you add water, they don't spread out evenly. Instead, they glom onto each other and form these little clumps that scientists call flocks. The big problem is these clumps trap a bunch of water inside them, which means that water can't help the mix flow. That's what makes it so stiff.
So the whole job of a superplasticizer is to get in there, break up those clumps, and set that trapped water free. The early versions did this with static electricity. Basically, they'd coat every single particle with a negative charge, so they'd all push away from each other, kind of like when you try to force the same ends of 2 magnets together. But the new, third-generation stuff, it does something even smarter. It uses a principle called steric hindrance, which is just a fancy science term for physically pushing things apart. These chemicals attach these long, bushy polymer chains to each cement particle. Think of it like this. Imagine forcing everyone in a crowded room to wear a huge, bulky backpack. Suddenly, they just physically can't get that close to each other anymore. That's what's happening at a microscopic level.
You know, this technology has a really fascinating history. It didn't just appear overnight. The second generation of these chemicals was really born out of the skyscraper boom in the 1970s. To build giants like the Sears Tower in Chicago, they needed unbelievably strong concrete. Then, in the 80s, engineers in Japan were facing a different problem. They needed concrete that could flow like water into really complex shapes for their architecture. So they invented the third generation to create something called self-compacting concrete. So let's zoom back out and bring this all together. What does all this chemistry actually mean for the world that we live in today? Because this isn't just something that happens in a lab. This is the tech that is literally building our modern cities.
And if you want the ultimate test case, the most extreme example, just look at the Burj Khalifa. To build the world's tallest building, they had to pump liquid concrete 600 meters, that's almost 2,000 feet, straight up into the air. The concrete mix had to stay perfectly fluid, maintaining its flow, or what they call slump, for hours during that long trip to the top. This would be absolutely physically impossible without the mind-boggling performance of those third-generation admixtures.
And this brings us right back to where we started this whole conversation, that giant 8% slice of global emissions that comes from making cement. Every single time a builder, anywhere in the world, uses a superplasticizer to take out that 100 kilograms of cement, they're taking a little bite out of that number, cubic meter by cubic meter, all over the planet.
So the big takeaway is this simple. It's a win, 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 win. This tiny, tiny chemical additive gives us cheaper buildings, stronger roads and bridges, faster and easier construction, and a seriously smaller carbon footprint. It is honestly one of the most impactful and maybe one of the most underappreciated technologies shaping the world around us.
It really makes you think, doesn't it? While we're all looking for these huge, grand solutions to our biggest challenges, maybe one of the most powerful answers has been hiding in plain sight this whole time, inside a concrete mixer. Just a few drops of a chemical with the power to literally reshape our world for the better?